So we've been talking about energy and waves. And energy and waves, if you go on further in physics, there's a lot to learn about them. But for the purposes of this course, it's a pretty straightforward way to think about it. This problem gives us that we've got a device that extracts energy from waves in direct proportion to their intensity. And we've got this device, it extracts 10 kilowatts of power for a 12-meter high wave. And the question asks, what amount of power would you get out of a 6-meter wave? So we know that this is about half the height of the wave, but it's not a linear relationship. So the givens are the heights of the waves and the power, and the unknown is what is the power if the wave's amplitude, that's the height of the wave, is 6 meters. So we've got a couple of equations. We know that intensity is power over area. That's our equation that has power in it. And we know that the problem gives us the energy is directly proportional to the intensity. The thing to remember about energy and waves is that energy is proportional to the amplitude squared of the wave. Okay? So if we know energy is proportional to the amplitude squared, then the intensity is also proportional to the amplitude squared. So if we cut the amplitude in half, then the intensity is actually going to decrease by 1/2 squared, which is 1/4. So you just take this 10 kilowatts, divide it by 4, and you get that the power extracted from the 6-meter high wave is actually 2.5 kilowatts. So the key to this problem is to remember that energy is proportional to amplitude squared. So hopefully that'll help you while you're taking your exam and doing the rest of your homework problems.